Младший лейтенант сидит в сторонке, бирюзовый взгляд, как у ребенка. Что-то не танцует он. Младший лейтенант с улыбкой странной запросто мог стать звездой экранной. Только 2 звезды упали на его погон. Telecomпany Douglas Productions and Svetlana Productions movie experiment very hard. Real and dummy AC voltage caps, AC DC voltage caps. Enjoy video. Of course, sponsor of program Douglas Konzel, director of stage Svetlana Konzel.
Okay, that was international pop star Svetlana Konzin singing some Russian song. And here's how far I've gotten. I'm not finished with this. I'm just kind of experimenting still, but what I'm doing is stat power inverter, AC out, feeds the primary right here, this coil, middle coil shorted out. The new thing I did is this secondary coil, I want it to have a lot of amps and not over 15 or 16 volts, and it puts out 13.8 volts AC. And you see I have actually 3 wires, the thick wire out of a microwave oven transformer, 3 of them, and they're all soldered in parallel, so it's a very thick wire coming out, and I get 13.8 volts AC, and I'm rectifying it with a full wave bridge rectifier, AC legs in here, and DC legs right into the cap. There's another way to do this where you have on one of the AC lines coming out of the secondary, you have this in series, so the power kind of is taken out sideways from one of the AC lines, and this is called vectoring. And this is not vectoring, it's just going parallel AC out from the coil right here and parallel DC out into the cap. That just happens to be what I'm doing right now. Now we have a flashing bulb over here. Before, if you saw my previous video, I had a 40-watt bulb in there, and it would flash just, I don't know, every 5-10 seconds. Just a quick flash. But I put in a 10-watt LED bulb, and then for the resonator circuit, you could call it, I have 2 40-watt bulbs in parallel, and these are in parallel to the cap bank here. Now, I haven't done anything to the cap bank. I haven't done anything. I'm sure this is not correct. It's like, and but this is 163 MFD. I'm kind of doing one thing at a time here. So the one thing I did was make this coil, so I rewound the coil so it has those really thick windings, so it has a lot of amps, and it doesn't go over, it's 13 point, it doesn't go over 16 volts, so it's not going to blow anything up. I was experimenting last night with this big cap bank. It kind of filled up, took a long time to fill. It wasn't really helping at this point, but I'll probably later on I'll use it, but not right now. But anyways, so what's happened is my idea is I have one inverter powering it. Here's the white cord. There's a fuse over here and it goes into the primary, okay? Very simple. AC output from here. Also, these don't have 120 volts. They have about 100 volts coming out, 103 volts coming out of them. I have 4 of these and they all said the same thing, 103 volts AC with a 12 volt battery feeding. Now my whole idea is I want to take the DC out that I'm getting and run it into here, into another inverter. And this is called the dummy work inverter, because now I can simulate the reality if I was looping this. I have the same inverter and I have somewhat the same load predicted. So my load right now in this dummy inverter is the inverter itself. It takes about 4 watts, 0.045 milliamps. I mean 0.045 amps. So it's 45 milliamps and 12 volts to run this thing with no load. And so then I have the load of this 10 watt light over here. It says 10 watts on the bulb. I don't really know the real power going in, but it's my simulation. And for some reason it's flashing like this. It has to do with this, well, I guess you'd call it a tank, resonator tank circuit. All these 163 MFD, which has the light in parallel. I'm sure this is not correct. I've probably gone way below or way above the resonating capacitive microfarads to create ferroresonance and everything else that I'm talking about. But I'm going to adjust this later. I'm going to be doing this later. But anyways, I got this interesting effect. This light is powered by the dummy resistor. So I could take the DC out to the dummy resistor. That's this and this. The DC out from this, which is right here, the red and the green and black. Is that right? No, it doesn't matter. So the DC out of this being filled by this secondary that has its AC out go into the full wave bridge. The DC out goes up into the cap. This cap goes into the DC input of this dummy inverter. So this cap is running this. Now in the perfect world, it's going to just be, you take out, what I would do is take this DC out from the cap and put it across the battery down here, just for starters, and then pull the battery out of the circuit and just have this DC cap run everything in a loop. That's the idea here. But right now I could take this pretty fast flashing 10 watt bulb, take that power out, shove that into this battery down here, and then pull the battery out of the circuit, and maybe this flashing circuit would sustain everything. I doubt it, so I'm not going to try it right now, but I think if I get this Resonator cap bank, I'm going to start calling it, of the right microfarads, it might be good. And right now I'm thinking that just instead of this flash, I could put a cap across this light bulb, make it so it doesn't flash, but that's just a thought. So anyways, here's what's going on. Primary has its 120 volts, 60 hertz into it, but it's actually only 100 because I'm using 103 because I'm using this inverter. I'm not using the grid. Middle coil shorted, and the A coil, the secondary coil, goes right into this cap bank here, just like that, and the cap bank comes out and goes into that light over there. I'm sorry, these lights over here. And they aren't flashing at all, and they're just getting a little warm because look at what's in the cap bank. Hardly any volts flashing around. But anyways, this light is supposed to create a ferroresonance, but whether it is or not right now, I don't know. So sorry about these drawings, but I want to go over this again. Why you want to use a three-phase transformer core is because when you short out the middle phase, it neutralizes the polarity. You can call it null or something. And naturally, if you, this is reverse, I'm putting it in A, and this is the secondary. But naturally, if you energize and excite this AC leg, the core is going to go into naturally north and south, south and north, north and south. Okay, so if you have the now the back EMF flux, I keep talking about this, is in opposed direction of the main current flow. So if it's going like this with this arrow, the back EMF, the magnetic force, the inherent, I'm not talking about flyback, that's going to go this way. Normally it's going to hit this south, and it's going to conflict, cause constriction and blockage. It's not going to want to go there. It's going to bounce back and cause a lot of extra draw. Let's say you just had a regular transformer, not a three-phase like this. Same thing. But when you have a three-phase transformer, you short out the middle coil. That south goes right through here and is attracted magnetically to the north. I've been through this before, but I want to pound people's brains with it. Goes over here, and it's magnetically attracted. The south ball or force of back EMF, magnetic force, is going to go right to the north, and it's going to energize this coil over here, and this will be a generator coil induced by reversed induction, you could call it, because it's reversed than the regular current flow. After it goes through here, maybe it only goes halfway through there, but it's going to energize this and create another energized coil similar to what originally happened here with the AC power input. And so you have another power module? No, you have another energized coil, which is going to be north and south again. And so now you're going to have a secondary, you're going to have another back EMF. This back EMF has already done its job. It's energized this coil. Now the coil is energized and it's north and south here. But you're going to have a back EMF coming out of it too. And that is going to be a north ball of flux that goes right over here. And this has been neutralized so that you don't get any blockage or restriction. And it's going to be north because this is south. So you have primary, then it creates power in the secondary. The power in the secondary has a bit back EMF. It's in opposite polarity, and it comes right across here, and it's north. And guess what? This is south. So it goes right up here, and it reinforces power in the primary. And it creates a magnetic loop that goes all the way around. And so now your back EMF, which is normally causing all these problems, is now taken care of, is what you can say. And it's doing work. So that's what's cool about that. So there's that. And so I want to go over this again too, because I watched my video before. They're good for watching to see what mistakes and things you leave out when you make a video. Okay, we're just dealing with the half wave here. What I just talked about, that's a half wave, sine wave. Here's the AC sine wave. And it's only this where all that happens. And then it's repeated, but upside down. Everything's opposite. It's repeated in the negative portion. And then it happens again. And then it happens again. That's the way that works. This core, the flow of magnetic back EMF through the core, what I just talked about. So it has at 60 hertz, which I'm dealing with because these transformer cores we use, they're made for 60 hertz. That's what they're made for. And they work really good at 60 hertz, but don't take it up to 600 hertz or it's going to be too slow to react. Anyways, so you have 8.3. Here's a full wave cycle. One cycle of AC, 360 degrees, is from this point to this point, and that's the zero line. So you have 16.6 milliseconds of a cycle, and so you really only are dealing with 8.3 milliseconds for that that core to do its job of circulating the back EMF around the perimeter, I call it, of the core, the three-phase core. Now, again about this paralleled light to the cap bank. So the idea, Tim Tron would say, you're resonating the load. Resonating the load, okay? So the load happens to be these lights over here. This has not been rectified to DC yet. I'm speaking of the AC initial cap bank stuff, the AC coming out here. That does get rectified, goes into the light, but meanwhile there's this AC that comes out of here, and it goes through these caps, which are actually a load in themselves, but the real load is these lights here. So there's a lot of argument and controversy that I should have a ammeter on one of these lines going to the lights, and that's your real power, R-E-A-L, power. But to me, that's not what it's about. It's not to measure it and prove it's not OU, or you only get a small percentage of power going in here. It's taken up by all the caps and all this stuff. The reason for these lights is to create a ferroresonance in the core. Because this is what I didn't really explain last video. The AC going into this cap bank, let's say this is it. So, and let's just deal with a half wave again. Fills up those caps, 163 microfarads. And right up here, the caps are as high as they're ever going to go, right up here at the peak. And right now I don't have very good voltage in the caps at all, but that's okay. That just happens to be what it is, because I haven't adjusted anything. So here it is, the caps fill up, and guess what? The polarity changes. It starts coming down. I'm not sure exactly where this would be, but when it's flip over of the AC, it's going to automatically dump those caps into the load of those lights at the AC flip over. So I'm assuming it's right here, but I might be wrong. It might be at the zero line. But anyways, they will, when the AC flips though, it will dump those caps into that light. At X, cap dumps to light. And then it happens again. It reaches the peak, the caps in the negative, they're going to fill up, negative wave are going to fill up to their peak. The AC is going to start going the other direction, and the cap's going to freak out and dump into the load. So this happens like that. Fill, dump, fill, dump. And reminds me of Pete Moss and his brother. Oh, never mind. Oh, Pete Moss and his brother Phil Dirt. Anyways, this is Phil Dump. So, I hear hydroplanes. Can you hear that? It's a Seafair here in Seattle. They have a bunch of hydroplane races down at the lake. So whatever, what was I talking about? So this is how you create ferroresonance in the core. And if you look it up on AI or Google it, will a load across a cap bank excite ferroresonance? I don't know if excite's the right word, but this causes ferroresonance in the core, and I imagine why is because a cap discharge is very violent and very quick, and that's what hits the core, the change in polarity. And so for some reason this is supposed to excite ferroresonance, and it's caused by this load being parallel to this Resonator cap bank. So, and in the past with different, I could have these things quite bright depending on the voltage, but I'm only putting in, see right now it's just 7 and 8 volts in there. So it's not doing much to that load, and I doubt it's really ferroresonating this like it should be. But I got this light to blink pretty fast. I wasn't planning on it or anything. It's just another surprising thing. And it might be that this is enough to self-sustain. But I want this to not only self-sustain, but have a lot of power left over. Real free energy device. So, two more things I want to be doing with this is I like that it's putting out 13.8 volts from here. Very thick wine, so it's going to have a lot of amps. I want to try, before I adjust this cap bank, I want to try the full wave bridge with its AC legs in series on one AC line. So you have the AC like this coming out of it. You break it in the middle, and then you have one AC leg here, one AC leg here. And so it's kind of brings out the AC to rectify it sideways, more or less. They call it vectoring. I think I mentioned that at the very first. But this is not vectoring. This is just parallel in, parallel out. So I mentioned that. So I want to change this. It's probably next thing I'll do is see what happens when I change it. And the cap will definitely be part of the tuning of the vectoring. And maybe this cap will have something to do with it. I don't know. But anyways, also I want to just get this working as it is without the DC side of it going on. Go back to kind of square B. Square A is just get this putting out power. Square B is put these AC cap, resonator caps in parallel to the output. Of the secondary. In parallel to the output of the secondary, have these, and then I'm going to keep changing the cap values with that light across it until I get the maximum amperage going on. And it might be this light needs to actually be across, maybe the load actually needs to be the load that is going to loop it, which would be the dummy inverter. So maybe I should do something like that, but I don't know. But anyways, I got this light flashing. So some more testing to go on. And I think I mentioned I tried out, these didn't really work. I could only get the volts up with these in the picture. I could only get the volts in the cap up to like 9, and then really slow going up to 10. Really slow. And didn't seem practical right now, but anyways. Okay, so that's good enough. Thanks for watching.